What if Earth once hosted a chapter of life that feels less like biology and more like a cosmic riddle? Scientists call it the Ediacaran Period, a strange, fleeting age 63.5 to 5041 million years ago, when life forms appeared that looked nothing like the creatures that came before or after. Soft, flowing, almost abstract in shape. Some looked like fronds, others like discs pressed into the seafloor, and some, well, let's just say they seemed designed more for dreams than for survival. And here's the question that keeps some of us awake. Were these beings truly Earth's first grand experiment in complexity? Or leaning close for this one, could they have been something else? Visitors from elsewhere, cosmic prototypes, or even the forgotten traces of an ancient galactic civilization? Of course, the textbooks won't phrase it that way, but imagine it. Alien architects seeding oceans with peculiar designs, a hidden experiment playing out beneath waves that shimmered under an ancient sun, creatures drifting in silence, no eyes, no mouths, no bones, just strange bodies gliding through primeval seas like living hieroglyphs. And we, millions of years later, find only their faint imprints in stone. Are these fossils simply the natural ancestors of all that came next? Or are they messages from somewhere else, written in a language we've yet to decode? So tonight, let's take a gentle dive into that mystery. Picture the oceans of long ago, glowing softly, filled with forms that seem to have slipped from another world. As you drift into the story, share your thoughts in the comments. Were these beings Earth's first experiment, or someone else's? And if you enjoy wandering into mysteries like this, tap like, subscribe, and let's sink together into the strangest age our planet has ever known, the Ediacaran Period. Even the name feels like a riddle, whispered across time. It sits at the threshold of the known and the unknowable, a late chapter of the Precambrian age, unfolding just after the frozen grip of the cryogenian ice ages. Imagine a world that had been nearly locked into a planetary snow globe, oceans capped with ice, continents shrouded in endless white. Then, with a breath both violent and tender, Earth thawed, and out of that thaw, out of that planetary rebirth, something strange happened. Something so strange that even now scientists squint at the fossils, scratch their heads, and admit we don't really know what we're looking at. This is the Ediacaran, a window into a world that does not fit, a door left ajar into a chapter of Earth's story that feels written in a language we can see but cannot read, creatures without precedent, forms that bend the rules of biology, whispers of a forgotten experiment that may not even belong to Earth at all. Was it the dawn of animal life as we know it, or a cosmic seed sprouting briefly before vanishing forever? Scientists use cautious words, hedging bets with terms like enigmatic and problematic, but conspiracy-minded dreamers, and who among us doesn't secretly enjoy being one of those lean in and ask the questions? Science dares not. Were these beings homegrown, or were they planted here, gifts or tests from elsewhere in the galaxy? To appreciate the strangeness, you have to picture the stage. Earth had just staggered out of the cryogenian, one of the most severe ice ages in the planet's entire history. For millions of years, glaciers stretched nearly from pole to equator, a world encased in frozen silence. The thaw would have been cataclysmic. Volcanoes belched heat, greenhouse gases spiked, oceans roared back to liquid life. Out of this planetary chaos, life did something audacious. It began to grow large, visible and soft. After billions of years of microbial obscurity, Earth unveiled shapes that were, at once, utterly alien and eerily deliberate. And this is where the problem begins. When paleontologists press their noses to the rocks of Australia, Namibia, Newfoundland, and Russia, they see the outlines of these beings. Impressions faint but persistent, like fingerprints pressed into stone, and yet they do not line up neatly with the evolutionary tree we've come to trust. They are not plants, not fungi, not animals in any familiar sense. They are not microbes, yet they are not quite the ancestors of today's biodiversity either. They exist outside the categories. They laugh at our filing systems. They refuse to tell us what they are. If evolution is supposed to be a branching tree, with roots deep in the Precambrian and leaves spread out across the Cambrian explosion, then the Ediacaran organisms are more like strange ornaments, someone glued onto the trunk when no one was looking. Do they represent a failed experiment, life trying out a set of body plans that were later abandoned? Or are they a clue that Earth was seeded with forms that had already been designed elsewhere by forces unknown? The conspiracy theory writes itself. Picture some galactic gardener, some ancient intelligence beyond our comprehension, scattering spores across worlds like a cosmic Johnny Appleseed. Most planets yield nothing, barren rock or gas giants that swallow hope whole. But Earth was different. Earth was recovering from ice, freshly warmed, oceans brimming with minerals, chemistry buzzing with potential. If you wanted a laboratory, if you wanted a test site, would you not choose such a world? Would you not drop in a few strange prototypes just to see what might take root? The Ediacaran could be that experiment, a phase of testing that left only cryptic imprints behind, like a researcher closing their notebook and moving on. And yet, science insists on restraint. The fossils exist. They are real. Their shapes are undeniable. But interpretation, that's where the debates rage. Some say they were early animals, ancestors of what would one day crawl, swim, and fly across the Cambrian seas. Others argue they were something else entirely, a unique lineage that rose, flourished briefly, and then died out, leaving no descendants. The Ediacaran may represent an entire kingdom of life now vanished. Imagine that, an entire domain of biology erased from Earth's memory, except for faint outlines in sandstone. That possibility alone is enough to keep a geologist up at night. But the conspiracy whisper remains. What if they didn't vanish? What if they left, taken away like experimental equipment after the lab closed? Perhaps their disappearance isn't extinction but retrieval. Perhaps they were never meant to stay. A shiver runs down the spine at the thought. Earth as a testing ground, a trial version of biology, and then when the results were noted, the prototypes withdrawn, leaving us to stumble forward on our own. Of course, not everyone entertains such cosmic tales. Many scientists remain firmly earthbound, focusing on geology, chemistry, and the conditions of that peculiar time. They note how the end of the cryogenian opened ecological space, how oxygen levels may have risen, how nutrients surged into oceans, creating conditions ripe for complexity. That alone could explain why life suddenly ballooned into such curious forms. But even here, the mystery lingers. Why these forms? Why then? Why shapes that so stubbornly resist fitting into later evolution? The Ediacaran remains the square peg in the round hole of biology. Think of it this way. If you flip through the book of life page by page, you expect a continuity. Single cells, colonies, multicellular forms, sponges, worms, fish, reptiles, mammals, humans. But then on the page labeled Ediacaran, the handwriting changes. The script tilts sideways, the illustrations make no sense, and just as you begin to decipher it, the page ends, torn out, replaced by the Cambrian with its explosion of recognizable creatures. It is as if someone deliberately inserted a chapter from another book, then quietly removed it, leaving us to wonder what story we were almost told. No wonder conspiracy thrives here. No wonder dreamers speculate about alien gardeners or cosmic design. The Ediacaran invites it. It practically begs for it, because the alternative, the idea that life can simply invent such oddities, let them bloom for tens of millions of years, and then discard them without trace, is no less astonishing. Whether seeded from the stars or born from Earth's own hidden genius, the outcome is the same, a biological gallery so bizarre that even now, 2 centuries after their discovery, we still argue over what we're looking at. And let's not ignore the humor in it. Imagine the scientists at conferences, sipping coffee, clicking through slides of incomprehensible fossils, and finally admitting, we don't know what these are. It's one of the few places in science where shrugging is considered a valid position. They have names, categories, hypotheses, but in truth, the Ediacaran is the planetary equivalent of a doodle in the margins, something that exists, that clearly mattered, but that refuses to tell us what it means. If biology is a carefully plotted novel, then the Ediacaran is the absurdist short story slipped into the middle, confusing everyone and delighting conspiracy theorists in equal measure. And think too about timing. After the brutal freeze of the cryogenian, Earth could have rebooted with simple microbes, as it had so many times before. Instead, it produced complexity, large multicellular life with forms extravagant and inexplicable. Was it coincidence? Was it inevitability? Or was it, as the conspiratorial heart suspects, intervention? Timing is everything in experiments. You choose the moment when the system is most vulnerable, most ready to change, and then you introduce the variable. The Ediacaran could be that variable. Of course, no one can prove such claims. The rocks tell us only so much. They preserve impressions, not intentions. They give us shadows, not answers. And perhaps that's why the Ediacaran fascinates. It is a mystery without resolution, an open-ended question carved into stone. Whether you are a scientist, a skeptic, or a dreamer of cosmic conspiracies, you cannot help but feel the pull of that enigma. These forms existed. They lived, they died, and they left marks that survived 500 million years. That fact alone is extraordinary. That we do not understand them makes them irresistible. So let us lean into the wonder. Let us indulge the possibility that the Ediacaran was more than just biology's awkward adolescence. Perhaps it was Earth's first attempt at conversation, a whisper to the cosmos, a statement that life could be stranger, grander, more diverse than we imagine. Perhaps it was a message left behind. Look what is possible, even here. And if so, then the conspiracy theory is less about aliens seeding life, and more about life itself being alien, always reaching beyond what seems likely, always writing poetry in forms that baffle us later. The Ediacaran, then, becomes not just a period of time, but a philosophical mirror. It asks us how we define life, how we measure continuity, how we decide what belongs, and what does not. It challenges our anthropocentric arrogance, our belief that evolution is a straight road leading inevitably to us. The Ediacaran laughs at that idea. It says, life is bigger than your categories, stranger than your logic, older than your comprehension. It is Earth's reminder that the story of life is not ours alone, and that even on our own planet, we may be surrounded by mysteries we cannot frame. And maybe, just maybe, that's the joke. Perhaps the Ediacaran is the punchline of the universe, a cosmic prank slipped into the fossil record. Here, it says, is a gallery of creatures you will never understand. You will argue, hypothesize, invent theories, but you will never truly know. Enjoy the puzzle. And we do, because mysteries like this are fuel for both science and imagination. They keep us searching, keep us awake, keep us curious. Without them, the past would be nothing but a dull chronology. With them, it becomes a story, a drama, a conspiracy in stone. So when you hear the name Ediacaran, do not think of it as just another geological period, a bracket of millions of years tucked between greater events. Think of it as Earth's great secret, a door into a world that was too strange to last, but too important to erase completely. A world that may have been an experiment, a dream, or a message. A world that whispers across time, I am not what you think. I am more. And as you drift into sleep tonight, let that thought linger. Imagine a planet thawing from ice, bursting with soft and impossible forms. Imagine scientists and storytellers alike squinting into the fossil record, trying to decode a script that seems written by alien hands. Imagine Earth itself chuckling softly, keeping its secrets. The Ediacaran was real. What it meant, well, that's the part we may never know. And maybe that's the point. When you picture life, you probably imagine something with eyes, with a mouth, with limbs or roots, or at least some recognizable way of navigating its existence. We expect creatures to have fronts and backs, insides and outsides, a system to eat, to move, to survive. That is how Earth seems to work. And yet, there was a time when the rules were broken, when life assembled itself into forms so peculiar, so abstract, that even today the best scientific minds stare at their impressions in stone and admit they do not fit. These were the beings of the Ediacaran. And if you ever wanted proof that nature, or perhaps something else, has a wicked sense of humor, look no further. The Ediacaran organisms were large, soft-bodied, and multicellular. But from there the familiarity ends. Their shapes were not the animal silhouettes we know, nor the botanical outlines we might expect. Instead, they resembled discs pressed flat, like cosmic coins, fronds that could have been plucked from a dream forest, quilted mats that looked like someone left pillows lying on the seafloor. They had no shells, no bones, no obvious organs, no mouths to eat, no stomachs to digest, no eyes to see, no legs to walk. Imagine life without any of the features we think life requires. Imagine shapes that could have been designed by a child doodling or by a computer running algorithms just to see what geometry emerges. Science, of course, has tried to classify them. Biologists love trees. The tree of life, the tree of descent, the branching diagram that shows how organisms relate to one another. But when the Ediacaran fossils were first uncovered, they did not slide neatly into any branch. They did not belong among the plants, nor among fungi, nor among animals, nor even among the simpler categories of sponges and microbes. They seemed to be something else entirely, something that forced the tree of life to sprout a strange new branch, or maybe even to grow sideways. It is as if evolution held a brief brainstorming session, tried out some bizarre designs, and then abandoned them without explanation. Some scientists, with sober faces and careful words, say perhaps they were an early experiment in multicellularity that left no descendants, a failed attempt that was swept aside by the great Cambrian explosion that followed. But conspiracy-minded dreamers hear that phrase, fail attempt, and cannot help but ask, failed by whose standards? What if they were not failures at all, but visitors? What if they were travelers from elsewhere being seeded here, who could not adapt and so left only fossils as postcards of their journey? Or more provocatively still, what if they were not natural at all, but engineered, the products of a biological technology so ancient it is now indistinguishable from myth, life forms that may have been grown like prototypes in Earth's earliest laboratory? The strangeness of their bodies invites such speculation. Consider their flatness, as if they were designed to be viewed from above, like landing pads, like symbols stamped onto the planet. Their quilted patterns look like the stitching of cosmic fabric, squares and ridges that seem more architectural than biological. If you showed their outlines to someone who had never heard of the Ediacaran, they might think they were symbols from an alien script, letters in a language too old to read. And in some ways, they are Earth's forgotten alphabet, the lost script of a biology that doesn't fit the rules we know. And here is the delightful problem. Without mouths, without stomachs, without eyes, how did they live? How did they eat? How did they reproduce? The textbooks give tentative answers, ideas about absorbing nutrients through their surfaces, about reproducing by spreading out like mats, or budding like strange fractal organisms. But these are guessing. The guesses highlight just how far the Ediacaran creatures sit outside of our comfort zone. Because when you really think about it, life without a mouth is not just unusual, it is almost philosophical. It suggests a way of being that is not predicated on hunger, on pursuit, on the constant devouring that defines most of biology. It suggests something gentler, stranger, perhaps even more alien. And so the conspiracy theories keep spinning. Maybe these beings were not Earth's at all. Maybe they were stranded here, cosmic castaways that drifted across space, hitching rides on comets, or carried deliberately by intelligences older than humanity can imagine. Perhaps Earth was a kind of quarantine, a test site where these shapes could settle temporarily. Perhaps they were messages, living sculptures meant to be found by future minds, puzzles written not in stone but in flesh, pressed into stone. Scientists, to their credit, rarely say such things out loud, but even they cannot resist the allure of the mystery. Entire conferences have been held where researchers argue about whether these organisms should be considered animals, whether they even belong to the same kingdom as anything alive today, or whether they represent a totally new category of life, an entire experiment that succeeded for tens of millions of years and then disappeared without trace. That possibility that there was once a kingdom of beings, now utterly gone, ought to chill us more than any alien conspiracy, because if Earth can forget a whole world of organisms, what else might be lost beneath its shifting crust? But the conspiratorial mind insists on asking again, or were they taken away? Suppose you were an ancient civilization, conducting bioengineering on a planetary scale. You create a set of prototypes, soft, malleable, diverse in shape. You let them flourish for a geological blink, observing how they interact. how they adapt. And then, when you've learned what you needed, you clean up the experiment. You remove most of the traces, leaving only faint impressions for the curious to find 500 million years later. The idea is wild, it belongs to science fiction, and yet it fits the evidence at least as neatly as any evolutionary model, because the evidence itself is so thin, so ambiguous, that imagination fills the gaps more easily than fact. The shapes themselves invite metaphor. The discs seem like coins from another currency, slipped into the geological record by mistake. The fronds look like bookmarks left in the story of Earth, markers of a chapter we cannot read. The quilted mats resemble pillows, as if Earth was dreaming and left behind the impression of its strange slumber. They are biological Rorschach tests. Whatever you see in them reveals as much about your own imagination as about the organisms themselves. Scientists see problems to be solved. Conspiracy theorists see proof of ancient visitors. Artists see abstract beauty. And perhaps the Ediacaran creatures were all of these things at once. The humor of it cannot be ignored either. Imagine aliens traveling across light years, arriving on Earth, and deciding to leave behind giant blobs shaped like pancakes and cushions. Not sleek machines, not towering structures, but soft, floppy, unrecognizable forms. If it was an alien message, it was either the strangest message in history or the funniest prank. Perhaps the joke was the point, to leave us wondering forever. Perhaps Earth itself is in on the joke, whispering, "Guess what these were? Go ahead, argue about it for centuries," and we do. Yet, behind the laughter is awe. These beings were real. They lived, they grew, they left marks strong enough to survive 500 million years of erosion, tectonics, and geological recycling. That in itself is remarkable. Most life leaves no trace. Most organisms vanish without fossilizing. For these soft-bodied entities to endure even as faint impressions is extraordinary. It suggests they were not fragile accidents, but something robust, something insistent, something that mattered in their time. And maybe that is the deeper truth. Whether they were Earth's own experiment or a cosmic import, whether they were natural or engineered, they show us that life does not obey the limits we place on it. Life can be flat, can be quilted, can be mouthless, limbless, eyeless. Life can look like nothing we recognize and still thrive. That lesson alone is worth the conspiracy, worth the wonder, because it tells us that the universe may be filled with forms stranger than we dare imagine, and that our idea of what life should look like is far too narrow. Some scientists have even proposed creating a separate classification for them, neither animal nor plant, but something entirely unique, a kingdom of the lost. That idea carries both humility and terror. Humility, because it reminds us we do not know everything. Terror, because it means Earth has seen kinds of life we can barely conceptualize, and then lost them forever. What if there are entire chapters of biology erased from the record? What if the Ediacaran is just the one chapter that happened to leave traces? How many other worlds of strangeness have come and gone without a whisper? In the end, the Ediacaran creatures are more than fossils. They are invitations. Invitations to stretch our imagination, to question our assumptions, to wonder whether Earth is as self-contained as we think. They are reminders that the line between science and conspiracy is sometimes only as thick as our ability to explain. And when explanations falter, conspiracies thrive. So were they aliens stranded here, unable to adapt? Were they artifacts of an ancient biotechnological project, left behind like forgotten prototypes? Or were they simply Earth's own invention too strange to last, erased by the tides of evolution? The truth is, we may never know. The fossils whisper but do not shout. They hint but do not reveal. And perhaps that is their gift, to keep us curious, to keep us awake at night, imagining discs that could be landing pads, quilts that could be cosmic cushions, fronds that could be alien antennas. The Ediacaran creatures laugh at our need for certainty. They refuse to be placed neatly in textbooks. They dance on the border between science and story, between data and dream. They are, in every sense, life too strange for Earth, and yet undeniably, stubbornly, part of Earth's own history. And if you ever find yourself staring at the night sky, wondering if life exists elsewhere, remember this: 500 million years ago, Life existed here, in forms we still cannot explain. We do not need to look to the stars for aliens. Sometimes, the aliens are already written into our rock. Close your eyes for a moment and let the imagination drift backward, far beyond human memory, past empires, past the earliest carvings, past even the faintest stirrings of complex life. You arrive at the Ediacaran, the last stage of the Precambrian world, where Earth was setting a stage unlike any it has built before or since. Here, the environment itself feels like a riddle. Oceans stretched wide and shallow, bathed in warmth, rich in minerals and nutrients. Continents sat bare and silent, vast expanses of stone unsoftened by forests or grass. It was a world stripped of distraction, a world that seemed prepared, even curated, as if waiting for something unusual to appear. Some say it was coincidence. Others whisper it was design. Was this the natural cradle of multicellular life, or was it a planetary laboratory arranged for experiments not entirely our own? The seas of the Ediacaran were unlike the oceans we know today. Modern seas teem with fish, reefs, kelp forests churning with predators and prey. But 500 million years ago, none of that existed. Instead, imagine immense, shallow basins, stretching across the single great ocean we call Panthalassa, a watery giant that wrapped the planet in a near-seamless blanket. These were not dark, cold abysses, but warm, sunlit waters where nutrients swirled freely. Picture a cosmic soup kettle kept at just the right temperature, seasoned with elements released by volcanic activity, stirred gently by tides under a closer moon. If you wanted to cook up a new kind of life, could you imagine a better kitchen? The continents, meanwhile, told a different story. They were barren, grey, lifeless stone. No forests, no grasses, no creeping moss to soften their edges. Rivers may have wound across their surfaces, but their banks were bare. Winds swept across landscapes without trees to catch them. Rains fell on naked rock. To us, such a world might seem bleak, but to the conspiratorial imagination, it looks suspiciously tidy. A laboratory without clutter, a controlled experiment where the land offered no competition, no distraction, leaving the oceans as the sole theatre for innovation. If Earth were a test tube, then the Ediacaran seas were the carefully measured solution, and the continents were the clean glass walls. Science, of course, has a measured explanation. After the cryogenian ice ages, when glaciers may have covered much of the planet, the meltwaters flooded the seas with nutrients. Phosphorus, iron, and other elements poured into Panthalassa, feeding microbial blooms that enriched the waters. Oxygen may have risen just enough to allow large multicellular organisms to thrive. Warmth returned, stability spread, and suddenly, conditions were ideal for life to take a leap. A reasonable explanation, yeah, but the conspiracy-minded voice in the back of the room leans closer and asks, why so perfect? Why then, after billions of years of microbial monotony, why did the Earth suddenly arrange itself like a cosmic incubator, complete with nutrient baths and sterile continents, just at the moment when complex life appeared? Coincidence or choreography? Picture the scene. A single super ocean, shimmering in the sunlight, wide shallows glowing like liquid glass. Nutrients drift in gentle currents, ready to be absorbed by any organism daring enough to grow larger than a microbe. Above, continents stand mute and rocky, their surfaces like observation decks overlooking the experiment below. If you were an extraterrestrial scientist, or perhaps a natural intelligence woven into the cosmos itself, would this not be the perfect arrangement? A cradle for the young, a petri dish for the bold, a safe zone for shapes too strange to endure elsewhere. Even geologists, in their most sober tones, cannot help but describe the Ediacaran world as special. They speak of shallow continental shelves, of expansive seafloors with stable conditions, of oceans layered with nutrients and light. They note how the chemistry of the water was tuned in ways that made new possibilities viable. Ideal, they call it, though they mean it in a scientific sense. But to the conspiratorial ear, ideal sounds suspiciously like engineered. How often does nature offer up perfection? How often does Earth itself seem to say, now is the time? The continents, stripped and empty, add to the eerie sense of intentionality. They stood as giant slabs of stone, silent sentinels around the edges of the seas. Without plants, there was no soil. Without soil, no forests. Without forests, no animals clambering onto land. The surface was still, austere, untouched. From orbit, had anyone been watching, Earth would have looked like a planet half-finished. Blue seas wrapped around grey land, like a painter had laid down the background, but never added detail. And perhaps that was the point. Perhaps Earth had been left intentionally bare, its attention focused on the oceans, the site of something extraordinary. It is tempting, almost irresistibly so, to frame the Ediacaran world as a laboratory, the seas as nutrient tanks, the continents as clean benches, the conditions as protocols laid out by a hand unseen. If you were running an experiment in life, if you were seeding forms not of this world into an alien ocean, wouldn't you want to minimize interference? Keep the system simple, remove distractions? That is exactly what the Ediacaran Earth looked like. Not messy, not crowded, not full of variables, but a place of clarity. And yet, for all its suitability, the environment raises more questions than it answers. If it was truly ideal, why did the forms it supported not continue into later ages? Why did they vanish, replaced by the riot of recognizable animals in the Cambrian explosion? Perhaps the laboratory was temporary, designed for short-term trials. Perhaps the test was completed, the results noted, the experiment concluded, or perhaps the environment itself changed, withdrawing the conditions that had made these forms possible. Was it Earth shifting naturally, or was the laboratory closed by the same hand that opened it? Scientists resist such notions, but even they confess confusion. They agree the Ediacaran seas were nutrient-rich, oxygenated in patches, warm and stable. They agree such conditions could allow multicellular organisms to thrive. But when asked why the organisms were so strange, so unlike anything before or after, they shrug. The environment explains survival. It does not explain form. It cannot explain why life chose discs, fronds, and quilted mats instead of heads, eyes, and limbs. It cannot explain why the stage was perfect and the actors so unfathomable. And here lies the heart of the conspiracy, the sense that perhaps the actors were not Earth's at all. Perhaps the environment was prepared, not for evolution's natural experiments, but for experiments imported from elsewhere. Imagine ships unseen sprinkling spores into warm, shallow waters. Imagine cosmic gardeners scattering designs into seas prepared for growth. Imagine Earth's barren continents serving as watchtowers for observers who never intended to stay. To skeptics, it sounds like fantasy. To dreamers, it sounds like the only explanation that fit. What is undeniable is that the Ediacaran environment was transitional, a bridge between worlds. Before it lay billions of years of microbial obscurity, after it lay the Cambrian explosion of animals we recognize, and between them stood a planetary stage set for a performance unlike any other. It was a world of shallow oceans glowing with nutrients, where complex life rose briefly in forms that baffled reason. It was a world where continents sat silent, barren as if deliberately set aside. It was a world that whispered possibilities far beyond natural selection alone. And so the Ediacaran environment remains a paradox. To science, it is the cradle of multicellularity, the natural outcome of geology and chemistry converging at the right moment. To conspiratorial imagination, it is a laboratory, a designed arena where something or someone chose to try out life. To both, it is a mystery that refuses closure. The oceans were too perfect, the continents too bare, the timing too precise. Coincidence is possible, but coincidence repeated at this scale begins to resemble intention. As you drift into thought, imagine standing on the edge of one of those continents, gazing out at the Ediacaran seas. No trees rise behind you, no birds wheel overhead, no grass brushes at your feet, only stone and wind on land, and before you endless shallow waters shimmering with sunlight. Somewhere beneath those waters, forms stir, shapes too strange to name. You cannot see them from here, but you sense them. You sense that the ocean itself is alive with experiment, and you wonder, not for the first time, whether you are looking at a planet in its natural state, or a laboratory arranged by forces unknown. The Ediacaran is gone now, buried in stone, its oceans drained into time, its continents remade into the familiar world we know. But the whisper remains. When we study the rocks, when we trace the chemistry, when we reconstruct those barren continents and shallow seas, we feel it, Earth says quietly. Here is my secret. Here is my laboratory. Guess what I was doing? And we, still baffled 500 million years later, can only guess. If the Ediacaran creatures were actors in a play too strange for our comprehension, then their stage was the climate itself, a planetary backdrop so unusually balanced, so strangely well suited, that it feels less like coincidence and more like choreography. Imagine a world where the thermostat was set between 15 and 25 degrees Celsius. Not too hot, not too cold, the range we humans today would call comfortable. Imagine oxygen slowly climbing toward 10, perhaps even 15% of the atmosphere, just enough to fuel large bodies, but not yet the lush 21% that makes our present breaths easy. Imagine carbon dioxide still high, greenhouse gases filling the air with warmth and vigor, feeding the chemistry of oceans and skies. Picture rains falling in torrents along coastlines, drenching shallow basins, while far inland, continents baked into desert silence. That was the Ediacaran climate, a world in balance, a world prepared, a world suspiciously perfect for mysteries we still cannot explain. Science, with its steady voice, tells us this was the natural outcome of tectonics, of chemistry, of a planet recovering from the cryogeny and ice ages. Volcanoes had poured carbon dioxide into the sky, raising global temperatures. Ice had melted, seas had warmed, weather systems had stabilized. Oxygen, released by microbial pioneers, seeped into the air in growing amounts, making new metabolisms possible. The stage was thus set for multicellularity to thrive. That is the scientific story, neat and reasonable, and yet, if you step back, tilt your head, and look at the numbers with a conspiratorial squint, you cannot help but notice how much the Ediacaran climate resembles a carefully tuned system, like a laboratory thermostat adjusted not by chance but by intent. 15 to 25 degrees Celsius. Think of it. A narrow band of warmth, consistent across millions of years. Too high, and the seas would have boiled with instability, storms scouring life away. Too low, and the planet might have frozen once more. Instead, the dial was set in the middle, as if someone had reached across the cosmic control panel and clicked the knob to ideal. Add to this the oxygen rise, 10 to 15%, too little, and large multicellular life could not have survived. Too much, and fire might have ravaged a barren landscape. But here again, the value fell within a sweet spot. Enough to fuel life, not enough to destroy it. Then carbon dioxide, high compared to today, pumping greenhouse warmth into the air, amplifying the balance, rain patterns that concentrated water where seas met land, deserts stretching inland, to remove unnecessary clutter. Could one design a climate more suited for strange new life to appear? The skeptic insists this is all chemistry, geology and luck. The conspiratorial whisper insists this is design. Perhaps the Ediacaran climate was Earth's first great act of terraforming, not by humans, not by chance, but by forces outside our comprehension. Was it tuned by alien engineers, adjusting knobs of temperature, oxygen, and rainfall? Was it a planetary trial run, a petri dish world under perfect laboratory light? If the creatures of the Ediacaran did not look like earthly descendants, perhaps that is because their conditions were never truly Earth's to begin with. And here is where the humor sneaks in, because one cannot help but imagine the scene in absurd detail. An alien technician leaning over a console, muttering, "Right, let's set this planet to 20 degrees, sprinkle in some carbon dioxide, nudge up the oxygen. There, that should do. Let's see what happens." It sounds ridiculous, like a cosmic cooking show, but then again, what else are we to make of the numbers? For millions of years, Earth ran on a climate tuned like a cosmic spa, warm seas steaming gently, oxygen bubbling, nutrients swirling, rainfall refreshing the edges. Too perfect, too comfortable, almost as if Earth had been converted into an incubator. The deserts too add to the mystery. Far from the oceans, the continents lay dry and empty, winds scraping over stone, silence broken only by dust storms. Why so barren? Science tells us that without plants to hold water in soils, rains drained quickly back into the seas. But the conspiracy-minded imagination notes something else. Deserts isolate. Deserts reduce interference. In a laboratory, you want control, you want simplicity, you want areas that are silent so you can watch what happens elsewhere. Could the great Ediacaran deserts have been intentional blanks on the planetary canvas, ensuring that the real drama remained near the coasts where conditions were richest? It is speculation, yes, but speculation thrives when the facts align too neatly. Oxygen itself is suspicious. For billions of years, Earth's atmosphere contained almost none of it, a toxic gas to the life that then dominated. Then, slowly, it began to rise. By the Ediacaran, it reached just the level necessary for complexity. Why then? Why not millions of years earlier? Or later? Why did it plateau in just the right zone? Scientists explain it with microbial photosynthesis, with carbon burial, with feedback loops in the biosphere. But again, the conspiracy voice leans in. What if oxygen was introduced or enhanced deliberately? What if Earth was not merely evolving, but being prepared? Oxygen is rocket fuel for life. Someone or something may have known exactly how much fuel was needed. The rains also play their part in the riddle. Along the coasts, clouds gathered and broke, flooding the margins of the sea with fresh water, stirring nutrients, washing minerals into shallow basins. Inland, dryness ruled. It was a planet divided, wet edges, dry hearts. In terms of experiment design, this makes uncanny sense. Concentrate water and nutrients where life is meant to flourish, withdraw them elsewhere. Ensure that the test organisms do not stray too far. Keep them corralled near the margins. Was this natural meteorology or a clever planetary management strategy? Earth, if it were a character, might chuckle and say both. Carbon dioxide remains another clue. Levels in the Ediacaran were high, far higher than modern values, yet not catastrophically so, enough to warm the planet into stability, enough to drive weather systems, enough to maintain shallow seas at just the right temperatures. Carbon dioxide is a double-edged sword. Too little, and the planet freezes. Too much, and it cooks. The Ediacaran levels struck a balance. To science, this was luck, chemistry, and feedback loops. To conspiracy, it was calibration. Someone, somewhere, had a finger on the scale, keeping Earth in the zone of possibility. And then there is the timing. The Ediacaran came after the Cryogenian, after ice nearly swallowed the world. If one were planning an experiment, what better way to start than with a clean slate? First, freeze the planet, scrub it down with glaciers, reset the biosphere, then thaw it, flood the seas with nutrients, warm the air, and begin again. The Ediacaran climate was not merely comfortable, it was post-apocalyptic comfort, as if Earth had been wiped, reset, and carefully restarted. Science calls it recovery. Conspiracy calls it renovation. What is most frustrating and most delightful is that even with all our data, the Ediacaran climate does not explain the strangeness of its life. We can say that oxygen allowed large bodies, we can say that warmth allowed stability, we can say that rain carried nutrients into shallow seas, but none of this tells us why the forms of life were so utterly alien to our eyes. The climate provided the conditions, yes, but conditions alone do not determine shapes. Something else guided them, or something else designed them. Science shrugs, conspiracy winks, and so the Ediacaran climate becomes a character in its own right. Warm, generous, perfectly tuned, but also deeply suspicious. It was a climate that seemed to smile and say, yes, life, grow here. Grow in ways no one will ever understand. Was it Earth's own genius? Or was it a cosmic puppeteer pulling levers we cannot see? The data cannot decide. The numbers remain on the page, teasing us. 15 to 25 degrees Celsius, 10 to 15% oxygen, high carbon dioxide, rain at the coasts, deserts, inland, perfect, perfect, perfect. Too perfect. That is the question. Imagine walking through such a world, if you could. Air warm, breathable, but heavy with carbon dioxide. Skies hazy with moisture near the shores. Storms breaking with drama. Thunder rolling over shallow seas. Move inland, and the air dries, the heat bakes, the land lies bare. It feels engineered, it feels designed. Even without seeing the life within the seas, you would sense that the planet was holding its breath, waiting for something to emerge, waiting for mysteries that would one day leave us baffled. And perhaps that is the ultimate joke. Perhaps the Ediacaran climate was both natural and designed, both coincidence and choreography. Perhaps the universe itself is the conspirator, forever arranging conditions just so, forever whispering, "Let's see what happens." And we, stumbling across the remnants hundreds of millions of years later, are left to marvel, to argue, to wonder if we are reading Earth's diary or someone else's experiment notes. The Ediacaran climate, warm, wet at the edges, dry in the heart, rich in oxygen, high in carbon dioxide, was the furnace in which a cosmic secret was forged. Science calls it the cradle of multicellularity. Conspiracy calls it the incubator of alien dreams. Either way, it was perfect. Too perfect. And that is why we cannot stop asking whether perfection itself was the plan. Among all the strange forms that emerged in the Ediacaran seas, one stands apart, a shape so peculiar and yet so strikingly familiar that it has become almost an icon of deep-time mystery. Its name is Dickensinia, and even the syllables carry a certain weight, like the title of a forgotten myth. When you picture it, don't think of fish or coral or worm. Think instead of something far stranger, an oval body, quilted like a mattress, its ridges fanning out in perfect symmetry, pressed flat against the ancient seafloor. Some fossils stretch nearly 1.5 meters in length, large enough to dominate the sandy bottom like living rugs. Others were small, coin-sized tokens of the same design. They did not swim, they did not crawl in any way we would recognize. They simply existed, adhered to the seabed, creeping slowly at best, absorbing nutrients directly from the surface beneath them. And yet in their outline, in their uncanny geometry, they invite a conspiratorial thought. Was Dickensinia merely an organism, or was it something else? A biological flying saucer that never took off? A surveillance device from somewhere beyond the stars, disguised as light? The first impression of Dickensinia fossils is unsettling precisely because of their regularity. Many Ediacaran organisms look like random accidents, improvisations of tissue and symmetry. Dickensinia, by contrast, looks designed. Its rib-like segments stretch outward with mathematical precision, mirrored perfectly on both sides, like the careful work of an engineer. The central line runs down its length like a spine or keel, while the repeated units flare outward, giving it the appearance of a segmented disc, sometimes circular, sometimes elongated into an oval. To modern eyes, it resembles nothing so much as the classic imagery of a flying saucer, flat, patterned, symmetrical, hovering just out of reach of understanding. Only Dickensinia didn't hover. It lay upon the seafloor, imprinting its strange geometry into the sand, leaving fossils that we now read like mysterious glyphs. Science has tried to file it neatly into a category, and for decades the debates have raged. Was it an animal? Was it a fungus? A giant single-celled colony? Something plant-like? The fossils resist easy answers. They have no mouth, no stomach, no eyes, no limbs. Yet, chemical traces found in Australian specimens show the presence of cholesterol molecules, a hallmark of animal life. That discovery pushed Dickensinia closer to our branch of the evolutionary tree, suggesting it may have been one of the earliest true animals. But here the puzzle deepens. If it was indeed an animal, it was an animal unlike any that came after, an animal that looked nothing like worms, nothing like sponges, nothing like the crawling arthropods or swimming chordates that would later dominate the Cambrian seas. It was unique, a design tried once and abandoned. Or, as the conspiracy-minded might ask, was it not abandoned at all, but retrieved? Picture Dickensinia as a biological probe, seeded into Earth's oceans by a distant intelligence. Its quilted body could be interpreted not as tissues but as panels, absorbing chemical data from the sediment, monitoring the chemistry of a young biosphere. Its slow movements across the seafloor, visible in faint trails preserved in rock, might not have been for feeding at all, but for scanning, mapping, sampling. From above, had you looked down through the shallow Ediacaran waters, It might have appeared as a fleet of strange disks spread across the seabed, like a fleet of reconnaissance craft resting on the ocean floor. Were they living creatures? Or were they instruments camouflaged as life? The fossils do not answer, but their geometry makes the question hard to resist. And then there is their size. Dickensinia was not small. At up to 1.4 meters long, it was a giant compared to most organisms of its time. Why such largeness, when smaller forms would have been more efficient? From a biological perspective, perhaps size allowed more surface area for absorbing nutrients. From a conspiratorial perspective, size suggests utility. A device must be large enough to house its mechanisms, to gather sufficient data, to fulfill its function. One imagines them as strange satellites of flesh lying upon the ocean floor, transmitting information not to a nervous system, but perhaps elsewhere. The truth, of course, is that Dickensinia left no bones, no organs, no inner map. What we have are imprints, shadows of its body pressed into ancient sands, like the faint outlines of ships long sunk, and those outlines drive both science and imagination into overdrive. Scientists publish papers with careful titles: Affinity of Dickensinia Reconsidered, Conspiracy Dreamers Mutter into Microphones, Biological Sources on the Seafloor. Both groups squint at the same fossils. Both groups admit this does not fit. To picture Dickensinia in its world is to imagine an ocean floor dotted with these ovals, like strange rugs scattered in the shallows. Some small, some enormous, some elongated, some nearly round. They rested there, absorbing nutrients, leaving behind subtle impressions as they shifted. Fossil evidence even shows that they may have decayed in place, their soft tissues dissolving, leaving outlines that look eerily like bodies outlined in chalk after some cosmic accident. Scientists describe these decay patterns with technical language. The conspiracy-leaning mind sees something else: an abandoned fleet, sources left to rot when the mission was done. Even the name carries irony. Dickensinia. It sounds more like a town in the Midwest than the title of an alien enigma, but perhaps that is fitting. The most extraordinary mysteries often wear ordinary names, disguising themselves in plain sight. What makes Dickensinia most tantalizing is not just its shape or size, but its stubborn refusal to align with categories. Scientists finally leaned toward calling it an animal after the cholesterol discovery, but even then it was an animal that did not behave like animals. It had no mouth to feed, no gut to digest, no eyes to navigate, no obvious means of reproduction. How can you be an animal without the basic equipment of animal life? It is like calling a car a horse, because both can move, even if one runs on hay and the other on gasoline. Perhaps Dickensinia was an animal, or perhaps it was something that only mimicked one, a life form parallel to our definitions, a life form that shows us how narrow our categories truly are. And here the conspiracy grows juicier. What if Dickensinia was not only a visitor but a teacher? What if it was left here to demonstrate possibilities, to show Earth what life could be? A biological textbook written in flesh, spread across the seafloor, saying, look, this is multicellularity, this is symmetry, this is pattern. And once the lesson was given, once the Cambrian explosion was ready to take off, Dickensinia vanished, its task complete. We like to think of ourselves as the first intelligences to run experiments, but perhaps we were the experiment, and Dickensinia was one of the tools used to prepare the ground. Of course, there is another possibility, one equally eerie, that Dickensinia was a living machine. Imagine a probe not built of metal and circuits, but of cells and tissues, a probe that could heal, reproduce, adapt, a probe made not to survive in the vacuum of space, but to study the chemistry of a foreign seabed. Biological engineering is efficient. After all, instead of building machines to mimic life, why not build life itself, as the machine? Dickensinia might have been exactly that, a soft-bodied rover, a living drone, seeded into Earth's oceans 500 million years ago. If so, then its mission was successful. It survived, spread, left records. And we, much later, are the accidental readers of its black box. Yet science resists such flights. Science clings to data. Cholesterol in the fossils suggests animal affinities. Growth patterns suggest biology, not mechanics. Trails beneath them suggest slow locomotion in search of food. All reasonable, all true, as far as evidence can show. But even scientists, after explaining all of this, cannot say what Dickensinia was with certainty. It remains a riddle, and riddles are the playground of conspiracy. Imagine, then, Dickensinia as both things at once, an animal and a symbol, a creature of Earth and an emissary of something beyond Earth. Its oval outline, pressed into stone, becomes like a signature scrawled across time. We study it, we measure it, we argue over it. But maybe the point was never to be understood fully. Maybe the point was to leave us wondering, to remind us that even the deepest history of life contains traces that do not belong to our categories, or perhaps even to our planet. If you could see a Dickensinia alive, it would not have dazzled you with speed or ferocity. It would have lain there, unmoving at first glance, a soft oval quilted with ridges. You might have mistaken it for a cushion or a rug, or yes, a disc waiting to lift. Watch long enough, and perhaps it would have shifted slightly, creeping across the sand, leaving a faint trail, not dramatic, but deliberate, a presence you could not ignore. And if your imagination leaned conspiratorial, you might have felt a chill, as if being watched not by eyes, but by something stranger, a survey conducted not through sight, but through existence itself. Dickensinia is long gone now, vanished from the living world, present only as impressions in ancient rock. But those impressions speak volumes. They whisper of a chapter in life's story where the rules were bent, where biology blurred with something else. Was it Earth's first great animal? Was it a failed branch of evolution? Was it a biological saucer, an alien probe, a surveillance device wrapped in flesh? The answer may never come, and perhaps that is the most fitting legacy of Dickensinia, that it remains forever unresolved, forever a puzzle, forever a reminder that Earth's past is stranger than we dare to imagine. So when you see its fossil in a museum, flat, oval, ridged like a mysterious emblem, allow yourself to smile. Science will tell you it was a soft-bodied organism from 550 million years ago. Conspiracy will whisper it was a visitor from elsewhere, a biological machine that once lay upon the seabed. Earth itself, if it could speak, might say, "This was my special disk. Don't try to spin it, it won't fly." But it may still take your imagination for a ride. And isn't that, in the end, what Dickensinia truly is? A ride across time, a mystery pressed into stone, a flying saucer that never left the ground, yet managed to soar endlessly in the human mind. Among the strange gallery of Ediacaran life, one form rises tall, literally, and casts a shadow across the fossil record like some enigmatic sculpture left behind by hands unseen. Its name is Charnia, and when you see its outline in ancient rock, you cannot help but think of a leaf pressed into stone, a fern-like frond frozen in time. But Charnia was not a plant waving in the wind, nor was it a fern reaching for sunlight. It lived rooted in the dark of ancient seas, attached to the seafloor, stretching upward as much as 2 meters, its delicate branches fanning out like a tree that never knew the air. If Dickensinia was Earth's strange rug, Charnia was Earth's strange tree, but a tree of the deep, a tree of mystery. Its shape alone is arresting, a central stalk from which pinnate branches spread, each smaller branch dividing again, like a fractal pattern drawn by mathematics itself. To modern eyes, it looks like a stylized feather, or a great fern frond, or perhaps the mast of an alien antenna rising from the seabed. No mouth, no stomach, no eyes, no seeds, no flowers, no evidence of photosynthesis either, since it lived too deep for sunlight to reach. Instead, Charnia absorbed nutrients directly from the water, like some cosmic sponge disguised as a leaf. It was large, graceful, immobile, and utterly unlike anything alive today. The first discovery of Charnia was made in England, etched into rocks in Charnwood Forest. For decades, people had assumed such leaf-like fossils were just ancient plants. But when it became clear they predated any known land flora by tens of millions of years, the illusion broke. These were not plants. But if they were not plants, and they were not animals, then what were they? That question still hangs unanswered, dangling like a frond swaying in currents we cannot feel. Science has tried, of course, to assign Charnia a place. Some argue it might represent an extinct kingdom of life, a lineage that flourished for tens of millions of years and then vanished without descendants. Others suggest it may have been an early experiment in animal multicellularity, closer to corals or sponges, though its structure does not fit neatly with either. Still others propose it might represent a new way of organizing tissues altogether, one that Earth never tried again, but no answer is definitive. Charnia remains a riddle, and riddles, of course, invite conspiracy. To the conspiratorial imagination, Charnia is not just a frond on the seafloor, it is a cosmic tree, planted deliberately, a beacon or antenna rooted in Earth's oceans. Look at its symmetry, its perfect fractal branching. Doesn't it look designed? Doesn't it look as if it were built to catch signals, to resonate with something unseen? If an alien civilization wanted to plant devices that blended in as natural, wouldn't they look like this, immobile, leaf-like, growing in numbers across the seafloor? Imagine Charnia not as an organism, but as a bioengineered receiver, tuning into signals from distant stars, transmitting data about Earth's oceans back to whoever or whatever was listening. The image is absurd and thrilling. A forest of Charnia standing in the depths, swaying gently, silent sentinels of some ancient surveillance system. From above they would have looked like a garden planted by a hand too vast for us to fathom. Some grew tall as a person, others small as a hand. All followed the same basic design. Fractal symmetry, no eyes, no mouths, no obvious function other than to stand, to filter, to persist. Science says they absorbed nutrients. Conspiracy says they absorbed information. And then there is their persistence. Fossils of Charnia show that they lived for long spans of time, stable and enduring. They were not fleeting shapes, not failed experiments that flickered out instantly. They spread widely, appearing in multiple regions. From England to Canada to Australia, they were cosmopolitan in their presence, as though they had been seeded across the planet, deliberately, like a crop planted in many fields at once. Was it chance that they appeared globally, or was it distribution intentional placement to ensure coverage? Science, of course, leans toward the former. Conspiracy cannot resist the latter. What is most unnerving is how unlike modern plants Charnia truly was. Plants rely on sunlight, Charnia lived too deep. Plants anchor in soil, Charnia anchored to bare rock. Plants use roots, stems, leaves. Charnia used fractal branches of tissues we cannot categorize. It is as though evolution drafted an entirely new concept for plant-like being, one that did not require sunlight, one that grew tall for reasons we still do not understand. Was the height meant for nutrient access? Was it structural necessity? Or was it symbolic, a shape chosen not by survival but by purpose? The fossil record shows Charnia standing silently for millions of years, unchanged in form, as if frozen in design. Other creatures of the Ediacaran varied wildly in size and shape, some bizarre beyond belief, but Charnia remained consistent, elegant, recognizable. To conspiratorial minds, this reeks not of random evolution, but of intention. Machines remain the same because they are built to spec. Devices hold form because they serve a function. Could Charnia have been such a device, an organism engineered not to adapt, but to maintain a shape critical for its role? And yet, for all its alien aura, Charnia was also achingly beautiful. Imagine walking along a seafloor garden of these beings, fronds rising 2 meters above you, each branching delicately like frozen fireworks, swaying softly in the current. They must have shimmered as they caught particles in the water, their fractal patterns reflecting light in ways no stone fossil can capture. A forest under the sea, but a forest of neither plants nor animals, a forest of something else entirely. To swim among them would have been to enter an alien world without ever leaving Earth. That beauty only heightens the conspiratorial speculation. Perhaps they were not receivers at all, but monuments. Perhaps an ancient intelligence planted Charnia as art, as decoration, as living sculpture marking Earth as part of some vast galactic gallery. Why build pyramids when you can grow forests? Why carve stone when you can engineer organisms? The idea is absurd, yes, but then again so is Charnia itself. Absurdity is its nature. Even the fossil record plays tricks. Many specimens of Charnia are preserved in exquisite detail. etched into stone like pressed flowers, their branching fronds perfectly captured. They look less like fossils than like botanical illustrations, as if Earth itself were sketching diagrams in rock for future generations. Scientists look at these fossils and write careful descriptions. Conspiracy theorists look at them and mutter, "These are blueprints. These are messages." This is the cosmos, leaving us notes in the margins of geology. Science resists that temptation. Science says Charnia absorbed nutrients osmotically, pulling dissolved organics from the water. It grew fractal because fractals maximize surface area. It lived in the dark because that was the niche available. All reasonable explanations, but none of them feel complete. None of them explain why Charnia looks so much like a leaf when it is not a leaf, why it grew so tall without sunlight, why it maintained its shape so consistently across millions of years and thousands of kilometers. Science explains survival, but it cannot explain strangeness. And strangeness is where the conspiratorial mind thrives. Perhaps Charnia was indeed a cosmic tree, planted to mark Earth as inhabited, or to test its conditions, or simply to see what would grow. Perhaps it was a camouflage system, a way to disguise alien instruments as life. Or perhaps it was something even stranger, something beyond even our categories of machine and organism. A third thing, a hidden life form that still whispers through stone. If you could touch a living Charnia, what would it feel like? Soft as seaweed, firm as cartilage, smooth as glass? We do not know. Fossils give shape but not texture, form but not sensation. And so we are left to imagine, to speculate, to laugh at our ignorance. Science says, it was alive, and it absorbed nutrients. Conspiracy says, it was planted here, deliberately, for reasons we cannot yet guess. Earth itself, if it could speak, might say, "This was my leaf that never fell, don't pick it. It's not a salad." In the end, Charnia is both humbling and exhilarating. It is humbling because it reminds us how little we know, how much of life's history remains inscrutable. It is exhilarating because it opens the door to wonder, to speculation, to the thrilling possibility that the strangeness we find in stone is not just accident, but maybe, just maybe, intention. Whether planted by evolution or by alien gardeners, Charnia stands as a symbol of the Ediacaran's greatest mystery. Life that does not fit, life that does not explain itself, life that leaves us staring at stone and whispering, what on earth or beyond earth was this? So let the fossil of Charnia haunt you a little. Let its leaf-like fronds sway in your imagination. Picture the seafloor forests, 2 meters high, silent and strange. Picture them as cosmic antennas, as living monuments, as messages disguised as biology. Picture them as nothing we can name, and everything we can dream. Because Charnia may never give us an answer, it may always remain poised between science and conspiracy, between leaf and machine, between Earth and elsewhere. And perhaps that is its gift, a fossil that is not just a window into the past, but a mirror reflecting our endless hunger to understand, to explain, to imagine. And maybe, just maybe, that hunger is exactly what Charnia was planted for. If the Ediacaran period was Earth's grand rehearsal for life as we know it, then Spriggina was one of its most curious performers. Imagine a worm-like creature, only about 5 centimeters long, roughly the size of your little finger, creeping slowly across the ancient seafloor of what is now Australia. Its body was segmented, each part repeating the same basic pattern, giving it a rippling, articulated appearance. At first glance, it looks almost ordinary compared to the stranger Ediacaran forms. Not a disc, not a quilt, not a frond, but a worm. And yet, upon closer inspection, Spriggina is anything but ordinary, because within its tiny form lies one of the great riddles of early evolution. Was it the ancestor of arthropods, the mighty lineage that would one day give rise to trilobites, crabs, spiders, and insects? Or was it something else entirely, a prototype that never quite fit, a dead end in the evolutionary maze? Or, and here the conspiracy voice leans in, was it not Earth's at all? Was Spriggina in fact a cosmic worm, a little bioengineered robot planted in Earth's seas, carrying alien genetic code inside its segmented body? Its shape is deceptively simple. The fossil impressions show a flattened worm-like body, tapering toward one end that may have housed something like a primitive head. Segments run down its length, sometimes overlapping slightly, as if arranged like armor plates. It looks like a toy version of a trilobite, like the kind of creature a cosmic engineer might build as a prototype before scaling up to the armored arthropods of the Cambrian explosion. To modern eyes, it resembles an earthworm drawn by a perfectionist, or perhaps a mechanical centipede designed by a futuristic toy maker. There is an eerie neatness to its repetition, a mechanical regularity that makes one wonder whether nature alone was responsible for its blueprint. Scientists argue about its place. Some suggest Sprigina was an early arthropod ancestor, its segmented body hinting at the lineage that would soon dominate Earth's seas. Others think it might be closer to annelids, the segmented worms that still slither today. But the problem is that Sprigina doesn't fit neatly into either group. Its body is too flattened, its segments too ambiguous, its head too unclear. It shows some of the right signs, but not all of them, as if evolution was sketching ideas but had not yet finalized the draft. And so, like so many Ediacaran organisms, Sprigina defies classification. Scientists throw up their hands, muttering that it is enigmatic. Conspiracists grin and whisper, or maybe it was designed that way. Picture the scene on the Ediacaran seafloor. Tiny Sprigina crawls slowly, leaving faint trails behind, like messages written in sand. It was no predator, no hunter with eyes or claws. It crept quietly, feeding perhaps on microbial mats, absorbing nutrients as it moved. Yet even in its modest way, it was remarkable. A segmented body is a leap in design, a repeating unit that allows flexibility, strength, and modular growth. It is the kind of design that engineers admire, because once you have the module, you can repeat it endlessly, scale it up, diversify it. Worms, centipedes, millipedes, insects, lobsters. So much of later life depends on this principle. And there is Sprigina, 500 million years ago, carrying the template like a hidden blueprint. Was it the humble ancestor of an empire of arthropods? Or was it a foreign seed, a prototype left by someone else to demonstrate modular design? One can almost imagine an alien workshop, far away, where life is constructed not by chance but by intention. Let's try segmentation. The alien biologists might have said, building little worm-like organisms that could bend, ripple, adapt, and they deploy them into Earth's seas, watching from afar as these tiny machines explore the shallow floors. Too fanciful? Perhaps. But when fossils leave us puzzled, imagination creeps in, and Sprigina, with its mechanical symmetry and modular elegance, invites imagination more than most. The fossil record of Sprigina is centered in Australia, preserved in sandstones that once lay under shallow seas. They show impressions so clear that you can count the segments, see the faint outline of its head. It is almost like a photograph in stone, a snapshot of a little worm, frozen mid-creep. Some specimens even show evidence of movement, trails that suggest a deliberate, if slow, locomotion. To a paleontologist, this is precious data. To a conspiracy dreamer, it is something else. The footprints of a machine, the tracks of a cosmic rover built not of metal but of tissue. Humor sneaks in when you consider its size. Only 5 centimeters long. If this was an alien probe, it was the tiniest surveillance device imaginable. A worm spy, a micro-drone creeping across the seabed, disguised as biology. Perhaps its creators did not want to intimidate. Perhaps subtlety was the goal. Why send massive ships when you can send little worms, scattering them across planets, blending them into ecosystems, watching quietly through genetic sensors we cannot imagine? The absurdity makes it funny, but the fossil makes it tempting. Science, of course, keeps a straighter face. The segmented body, the faint head, the possible bilateral symmetry, these all hint at important evolutionary steps. If Sprigina really was an early arthropod ancestor, then it represents a critical moment, the dawn of bilateral animals with repeating units, the architecture from which so much of later life was built. But science also admits the gap. Sprigina has no preserved legs, no clear organs, no obvious mouth. The details that would let us pin it firmly to one lineage or another are missing. And so once again, the story is unresolved. Unresolved stories are fertile ground for conspiracies. What if Sprigena was not Earth's ancestor but Earth's import? What if its segmented body carried not just cells but codes, genetic instructions seeded from elsewhere, instructions that would later flower into trilobites, insects and all the crawling, buzzing, scuttling life we know today? A worm as courier, a worm as messenger, a worm carrying alien DNA across time. It sounds like science fiction, but then again, so does the fossil itself, a 5 centimeter segmented enigma pressed into stone for 500 million years, still resisting explanation. Even its name has a charm. Sprigena, named after Reg Sprigg, the Australian geologist who first studied such Ediacaran forms. But in its syllables you might hear something else, a name that could belong to a character in a myth, a sprite or a machine. Sprigena sounds almost playful, almost invented by a storyteller. And perhaps that is fitting, for it is both science and story at once, both fossil and fable. Imagine holding one of its fossils in your hand, a slab of sandstone with the faint outline of an oval worm etched upon it. Not dramatic, not monstrous, but quietly strange. You run your finger over the segments, counting them like bee. You wonder, am I touching the ancestor of arthropods, the seed of spiders and lobsters and flies, or am I holding the trace of an alien device, a tiny biological rover from a civilization lost to time? Both possibilities feel thrilling. Both leave you grinning at the audacity of nature, or at the audacity of whoever designed this work. What makes Sprigena enduringly fascinating is that it is both humble and profound. It is small, simple, easily overlooked, but it carries within it a template that changed everything. Segmentation is not trivial. It is the backbone of complexity, the modular principle that allows life to scale up. In 5 centimeters of worm lies the possibility of trilobites, of crabs, of dragonflies, of bees. All of them, perhaps, owe their origins to something like Sprigena. Unless, of course, they owe them to someone like Sprigena, a designer, an engineer, a hand unseen. Science ends its papers with cautious phrases, further research needed, phylogenetic placement uncertain. Conspiracy ends its whispers with a wink, cosmic worm. And Earth, if it had a voice, might laugh softly and say, "This was my special worm. Don't dig too deep. It's tiny, but it carries secrets." In the end, Sprigena remains what so much of the Ediacaran is, a question disguised as a fossil. Was it truly one of us, an ancestor, the beginning of a line that still walks and crawls and flies today? Or was it never ours at all? A visitor, a machine, a messenger from elsewhere? The fossil will not say. It lies in stone, silent, its segments like closed lips. And we, staring across 500 million years, cannot decide whether it is laughing at us or waiting for us to understand. And maybe that is the true beauty of Sprigena. Not that it was small or segmented or slow, but that it is still alive in our imagination as worm, as ancestor, as alien, as machine. It refuses to be pinned down, wriggles away from definition, just as surely as it once wriggled across the ancient seabed. So next time you see its fossil, tiny but distinct smile, science will tell you it was an enigmatic worm from Australia, perhaps the ancestor of arthropods. Conspiracy will whisper it was a cosmic rover, a worm machine, carrying alien code. Earth itself might chuckle and say, "This worm was my prototype, special, strange, unforgettable." And perhaps, in that moment you will feel what makes the Ediacaran so haunting, the sense that even the smallest creature can carry the largest mystery. If modern ecosystems are bustling metropolises, predators chasing prey, plants reaching for light, creatures darting, hiding, eating, fleeing, then the Ediacaran ecosystem was something entirely different. Imagine not a city, but a meditation hall. Imagine an ancient ocean floor where life moved slowly, if at all, where organisms did not bite, did not chase, did not kill, but simply existed, drifting or resting, absorbing nutrients quietly from water or from microbial mats that carpeted the seabed. No jaws snapping, no eyes glaring, no predators lurking, just stillness, silence, and strangeness. It was life in its earliest form of community, a kind of peaceful gathering where every participant seemed content to sit and sip from the ambient buffet of nutrients. Scientists describe it cautiously as a low-energy ecosystem. Conspiracy lovers describe it as something else, a cosmic experiment in pacifism, a test run by alien designers to see what would happen if you removed aggression from the recipe of life. Picture it. Shallow seas warmed by the sun, sediment coated with thin microbial films, and scattered across it, an array of creatures that neither hunted nor fought. They absorbed what they needed from the water, from the mats beneath them, or perhaps from chemical gradients invisible to us. They did not devour one another. They did not even seem to notice one another. It was an ecosystem of presence rather than action, of existence rather than conflict. To modern eyes accustomed to nature red in tooth and claw, this seems absurd. How could life flourish without the drama of predator and prey? And yet for tens of millions of years, it did. Science says this was simply a phase, a necessary prelude before the arms races of later ages. Without predators, organisms could grow strange and soft, experiment with shapes, test the waters of complexity. But the conspiratorial imagination finds the whole thing far too neat, an ecosystem with no predators. That sounds less like accident and more like design. Was Earth's seafloor in the Ediacaran not a natural community at all, but a controlled laboratory? Did someone or something set the parameters? No predation, no violence, only absorption and growth. In other words, was this not nature's ecosystem, but a pilot project, a prototype experiment in what life could be? The humor in this is irresistible. Imagine an alien committee gathered around a table planning their Earth project. One of them says, "All right, let's test out multicellular life, but let's keep it peaceful. No predators yet. We'll just see how they absorb nutrients, how they grow. Predation, we'll save that for phase 2. Another alien nods sagely. Yes, keep it calm, like a kindergarten before we let them out into the wild playground. And so Earth's Ediacaran ecosystem becomes the galactic equivalent of a nursery, filled with strange forms quietly existing, unaware that they were part of a much bigger game. And yet, for all the conspiracy, the science is just as fascinating. The Ediacaran world shows us that ecosystems need not begin with predator-prey dynamics. They can begin with something softer, simpler. Nutrient absorption is enough. Microbial mats provide a banquet. The water itself carries dissolved organics to be drawn in. Life does not need to chase and kill in order to survive. At least, not at first. This realization unsettles us, because it suggests that aggression is not inevitable. For millions of years, Earth hosted a peaceful community. Then later, competition and predation arrived, and everything changed. But in this earlier chapter, life was contemplative, even lazy. From a scientific standpoint, this makes sense. Without eyes, without mouths, without muscles, organisms could not hunt. They had to rely on simpler strategies. And yet, the very strangeness of these strategies baffles us. Absorbing nutrients directly through the body, living entirely off microbial films, remaining passive for entire lifetimes, it all feels alien to our sensibilities. We equate life with activity, with urgency, but here, life was patient, waiting, trying out designs without pressure. And here is where conspiracy sneaks back in. Because if you were designing an experiment to test new body plans, wouldn't you want a safe environment? Wouldn't you want to remove predators so that prototypes could develop without being eaten immediately? The Ediacaran ecosystem looks exactly like that, a safe testing ground, a sandbox for biology, where nothing got punished too quickly, where organisms could flourish regardless of practicality. Soft, fragile, bizarre, no problem. In a predator-free zone, even the strangest design can thrive. It is almost too perfect, too convenient, like the rules of a simulation set by a careful programmer. This peacefulness also creates a surreal image of the seafloor. Imagine drifting down into the shallow waters of the Ediacaran. All around you, life forms rest or sway gently. None move with purpose, none lunge, none flee. It is like entering a dreamscape, a living art gallery, where every shape simply exists. To modern divers, accustomed to fish darting and predators lurking, It would feel uncanny, too still, too staged, as if every organism were a sculpture placed deliberately, part of an exhibition titled Life, version 1. Scientists describe it with neutral terms, a low-energy ecosystem dominated by osmotrophy and microbial feeding. But those words mask the wonder. To see such an ecosystem would be to see an alien planet on our own Earth. No struggle, no chase, no hierarchy of predator and prey, just quiet coexistence. And perhaps this is why conspiracy thinkers insist it cannot be coincidence. Too odd, too peaceful, too controlled. It looks like a system built not by accident, but by intent. And let us not forget the humor of it. Imagine one of these creatures drifting lazily, absorbing nutrients like a sponge, and another next to it doing the exact same thing. No competition, no conflict, just two beings sitting side by side at the buffet, both sipping from the same invisible stream. "Don't mind me," one seems to say. "No worries," says the other. It is almost comical, like a cosmic dinner party where everyone quietly eats soup without talking. Was this really evolution, or was it a joke written by the universe itself? Yet within that humor lies profundity. Because what this ecosystem shows us is that life can be peaceful. Life can exist without aggression. Life can flourish simply by absorbing what is already given. It is a model of abundance, of simplicity. Perhaps alien civilizations, if they exist, might prefer such models, ecosystems without violence, where complexity emerges without the cost of predation. Perhaps the Ediacaran was not just Earth's beginning, but a demonstration for others. Look, life can be calm, life can be strange, life does not have to be war. And yet, science also admits a problem. This ecosystem, for all its calmness, does not explain the strangeness of the organisms themselves. Passive absorption explains how they survived, but not why their bodies took such odd forms. Why discs? Why fronds? Why quilted patterns? Why not simpler, more efficient shapes? Science says perhaps it was just experimentation, natural trial and error. But conspiracy says perhaps the shapes themselves had meaning. Perhaps they were signatures, messages, codes embedded in the bodies of beings designed not by Earth but by someone else. The ecosystem was the canvas, the organisms the writing upon it. And we, 500 million years later, stare at the writing and wonder, who was the author? So the Ediacaran ecosystem remains a paradox. To science it was a calm, low-energy world, a stepping stone toward the complex, competitive ecosystems to come. To conspiracy it was a laboratory, a sandbox, a cosmic nursery where alien gardeners planted prototypes and watched them grow. To humor, it was nature's joke, a silent dinner party under the waves, life without drama. All three interpretations have truth in them, and all three capture something essential. Perhaps the Ediacaran ecosystem was not only an experiment in life, but also an experiment in interpretation. A puzzle left for us, a fossilized whisper saying, life need not be what you expect. Life can be otherwise. Whether designed by Earth or by minds beyond Earth, it challenges our assumptions. It makes us wonder if ecosystems elsewhere in the universe might also begin this way, calm, strange, passive, before evolving into the turbulent theatres we know. And maybe, just maybe, that is the point. The Ediacaran ecosystem was a gift, a chapter of peace in a book, otherwise filled with struggle. A reminder that even on Earth, for a time, life lived without jaws and claws. A reminder that perhaps the universe itself values not only survival but also wonder, stillness, and strangeness. So when you think of ecosystems, do not only think of lions and zebras, sharks and fish, predator and prey. Think also of that ancient ocean floor, 500 million years ago, where beings lay still, absorbing nutrients, content in their quiet existence. Think of the possibility that it was a cosmic experiment, or perhaps just Earth's sense of humor, trying out peace before plunging into chaos. And remember, the fossils may be silent, but the silence itself speaks volumes. There is something haunting about the end of the Ediacaran period. For tens of millions of years, Earth's seas had been home to strange, soft-bodied organisms, forms that defied classification, lived without mouths or eyes, and decorated the seafloor like living abstractions. And then, almost imperceptibly at first, they were gone. No sudden bang that we can see, no clear catastrophe written in ash or impact craters. Just a fading, a dwindling, a vanishing act that left only mystery in its wake. To scientists, this disappearance is a puzzle with several possible explanations: competition from new Cambrian creatures, shifts in climate, rising oxygen levels, or even subtle geological upheavals. To the conspiratorial imagination, however, the vanishing is far too neat, too thorough, too well timed. What if the Ediacaran wasn't just extinction, but deletion? What if the strange experiment had run its course, and the evidence was scrubbed by design? Consider the timing. The Cambrian explosion looms immediately after. That riot of new life where creatures with eyes, shells, claws and jaws suddenly appear in dazzling diversity. It is tempting to see the Cambrian as the replacement party, sweeping aside the soft and passive with the hard and aggressive. The Ediacaran organisms, so fragile and strange, simply could not compete. Predators arrived, nutrients were devoured more quickly, mobility became essential, and just like that, the Ediacaran dream dissolved, giving way to a harsher, hungrier reality. That is one scientific explanation: natural competition. Out with the old, in with the new. Survival of the fittest, played at evolutionary scale. Another explanation points to climate. Conditions that once nurtured the soft-bodied forms may have shifted. Perhaps ocean chemistry changed, perhaps nutrient flows declined, perhaps warming and cooling cycles made life unstable. Oxygen levels, once sufficient for passive organisms, continued to rise. Paradoxically, this abundance of oxygen, so good for later animals, may have harmed the Ediacaran designs. Their soft bodies, evolved in low oxygen worlds, may not have handled the chemistry of a more oxygen-rich ocean. They withered, like delicate fabrics exposed to harsh light. Geological upheaval adds another possibility. Tectonic shifts, volcanic outbursts, changes in sea level, all could have conspired to erase the delicate communities. Life is always balanced on geology's knife edge, and when the crust moves, the biosphere trembles. A series of subtle disasters may have chipped away until the Ediacaran forms vanished, not in one apocalypse, but in a long sequence of challenges they could not meet. Science, in its cautious way, admits we do not know. It offers scenarios, probabilities, models, but it cannot point to a single cause. The Ediacaran simply ended. The organisms left no clear descendants. They vanished without farewell. And here, into that silence, steps the conspiratorial question: or were they erased deliberately? Because look closer at the pattern. These organisms survived tens of millions of years, flourishing across oceans worldwide. Then, almost on cue, just before the Cambrian explosion, they disappeared so thoroughly that only faint impressions remain. What are the chances of such total disappearance unless someone wanted them gone? What if the Ediacaran was never meant to last? What if it was a trial, a test conducted on Earth's seas, and when the results were complete, the prototypes were removed? It is an unsettling idea. The notion that some intelligence, alien or otherwise, might have overseen the rise of these strange organisms and then, unsatisfied or finished, wiped them away. In this version, extinction is not failure, it is closure. Imagine researchers shutting down an experiment, wiping the chalkboard clean, leaving only faint traces for the next occupants to puzzle over. The Cambrian explosion then becomes not a natural succession, but phase 2, the next test, the next round of designs, the harder, sharper, more mobile forms replacing the soft enigmas of the Ediacaran. Of course, this is speculation, but speculation thrives when the facts are strange, and the facts are strange indeed. No clear predators in the Ediacaran, then suddenly predators everywhere in the Cambrian. No hard shells, then suddenly armor plating. No eyes, then suddenly vision exploding across lineages. The contrast is sharp, almost scripted. Too sharp, say the conspiratorial voices, to be coincidence. It is as though someone closed one program and booted up another. Humor helps soften the dread. Imagine, for a moment, a cosmic laboratory assistant scrolling through a planetary checklist. Ediacaran organisms ran for 60 million years. Results. Weird. Okay, delete that folder. Now let's install the Cambrian package. Shells, claws, eyes, teeth. Much better. It sounds absurd, like an IT joke written at cosmic scale, but the fossils, silent, strange, do nothing to disprove it. And perhaps this is what makes the Ediacaran extinction so unsettling. It feels too neat, too complete. These creatures did not dwindle into familiar lineages. They did not transform slowly into what came after. They simply stopped. Evolution does not usually stop. It branches, it twists, it leaves traces. The Ediacaran left almost none. Scientists call them a failed experiment. Conspiracy theorists nod knowingly and say, exactly. But was it failure? Perhaps not. Perhaps the experiment was never meant to succeed. Perhaps it was meant only to test possibilities. What happens when life is passive? What happens when it grows without predation? What shapes emerge when there is no pressure to hunt or flee? The Ediacaran answered those questions. Strange discs, fronds, quilts, and ovals emerged. They thrived for millions of years. They showed what life could be under those parameters. And then, when the test was over, the parameters were changed. Predators introduced, eyes developed, shells hardened, the next phase began. From that perspective, the Ediacaran was not failure, but data collection. The extinction was not tragedy, but transition. Still, we cannot help but feel a pang of sadness. A whole world of organisms lived and died, leaving no heirs. They vanished so completely that even their classification is debated. Were they animals? Plants? Something else entirely? We do not know, and we may never know. They are ghosts in stone, shadows of a lost world. Science shrugs, conspiracy grins, Earth whispers, my secret is safe. There is a lesson here, though, beyond conspiracy. The Ediacaran extinction shows us that life is fragile, contingent, easily swept away. It reminds us that even successful ecosystems can vanish, that existence is not guaranteed. It humbles us, reminding us that the human story is built atop countless forgotten stories. We like to think of ourselves as inevitable, but 500 million years ago, an entire suite of organisms might have thought the same. They thrived for eons, and then they were gone. Who is to say we will not someday follow? And yet, even in their absence, they leave us wonder. The extinction is a mystery, but mysteries fuel imagination. Were they erased by geological change, by chemistry, by predators? Or were they erased by design, wiped from the record by hands unseen? Science leans one way, conspiracy another, both in their own ways, attempts to make sense of silence. Picture it like this. The end of a party. The lights dim, the guests drift away, the music stops. Plates and glasses are cleared, the floor swept. By morning you would never know a gathering had taken place. That is the Ediacaran extinction, a banquet of strange life that packed up and vanished, leaving only a few crumbs in the fossil record. Was it nature tidying up or someone else cleaning the stage for the next performance? The answer depends on how conspiratorial you feel, but either way the effect is the same. The Ediacaran is gone. Its life forms are mysteries pressed into stone. Its extinction is a story without an ending. Perhaps it was climate. Perhaps it was predators. Perhaps it was oxygen. Perhaps it was deletion. Earth itself, if it could speak, might laugh gently and say, don't ask too many questions. My secret is well hidden. And maybe that is the truth. The extinction is not just about organisms vanishing, but about us learning to live with the unknowable. Some chapters in Earth's story are not meant to be fully read. They are meant to tease, to haunt, to inspire. The Ediacaran extinction is one such chapter, a reminder that life is fragile, that mysteries endure, and that sometimes the greatest answers lie not in what survives, but in what is lost. So let us leave it there, with a smile at the absurdity. An entire world of organisms lived, thrived, and vanished, leaving us to argue over their fate. Science says they were swept aside by competition and climate. Conspiracy says they were erased by alien hands. Earth, ever mischievous, whispers, you'll never know for sure, and perhaps that is the most satisfying ending of all. A mystery that remains a mystery, a secret kept safe by time. When we look for the story of the Ediacaran, we are left not with living creatures, not with DNA strands, not with vibrant photographs, but with imprints pressed into ancient rock. These are the fossils, ghostly outlines, ridges and patterns etched into stone 500 million years ago. They lie scattered across the planet's surface, discovered in places as far apart as Australia, England and Russia, like pieces of a global puzzle waiting to be solved. And yet, for all their abundance and their clarity, they refuse to yield simple answers. The fossils of the Ediacaran are at once generous and stingy, generous in number, stingy in meaning. They show us shapes but not systems, bodies but not organs, impressions but not intentions. They are, in a word, mysteries. The fossils in Australia, particularly in the Flinders Ranges, are breathtaking in their detail. There, in sandstone beds that were once shallow sea floors, entire slabs are covered with strange impressions. Some look like discs pressed into dough, others like ferns or quilted cushions. Their outlines are crisp, preserved as if someone had carefully stamped them into the sediment, then lifted them away, leaving perfect molds. Walk among those rocks and you feel as though you are strolling through an alien art gallery, with each slab displaying patterns that defy easy classification. England offers another treasure, where the fossils of Charnwood Forest etched delicate fronds into stone. Russia adds to the story, with its own slabs carrying strange shapes like hieroglyphs, carved not by humans but by life itself. The distribution is global, as if the entire world was in on the same secret, leaving behind the same cryptic signature. Science explains the preservation in terms of geology. Microbial mats covering the seafloor created conditions that captured and held the impressions of soft-bodied organisms, preventing them from decaying before sediments hardened into stone. Over hundreds of millions of years, those stones were uplifted, tilted, and eventually exposed at the surface, where paleontologists stumbled upon them. That is the scientific account, neat and reasonable. But look again at those fossils, really look, and you might see something else. They are not chaotic, not messy, not accidental looking. They are patterned, symmetrical, almost deliberate. Too deliberate, some might say, which is why the conspiracy-minded cannot resist asking, are these fossils really just biological remains, or are they messages? Could the Ediacaran fossils be the universe's code, written in rock, left for us to decipher? The idea may sound absurd at first. Life forms as messages, but consider the parallels. The fossils are widespread, found on multiple continents. They are preserved with striking clarity, as though someone wanted to ensure they lasted. They are enigmatic, resisting all attempts to classify them neatly into plants, animals, or fungi. They are symbols, not words, but symbols nonetheless, repeated across space and time. Doesn't that sound suspiciously like a code, a series of pictograms etched into stone, waiting for a future intelligence, us to stumble upon them and wonder? Imagine for a moment that each fossil is not a creature at all, but a character in a language. The discs, the fronds, the quilts, the branching patterns, these are not bodies, but letters. Together, they form an alphabet written on the seafloor of an ancient world. And when we walk through the fossil beds of Australia or England, we are not looking at organisms, but at pages. We are turning through a cosmic book, 500 million years old, written in a script we cannot read. Science insists they were multicellular organisms. Conspiracy whispers they were glyphs. They were messages from elsewhere, encoded in biology, preserved in stone. The beauty of the conspiracy is how neatly it fits the problem, because science, for all its careful work, admits confusion. The fossils show multicellularity, yes. They show tissues and structures beyond simple microbes, but they do not show features we recognize as belonging to animals or plants. No mouths, no guts, no reproductive structures, no clear evidence of nervous systems. Multicellular, yes, but multicellular what? Science shrugs. Conspiracy grins. Multicellular messages, it says. Biological runes planted on the seafloor. And humor is impossible to resist here. Picture some ancient extraterrestrial engineer saying, let's not bother with satellites. Let's write our messages in living organisms. We'll design them to grow on the seafloor, then let the geology do the rest. In 500 million years, they'll fossilize perfectly. The locals will dig them up and wonder what they mean. Perfect. It is absurd, of course, but then you look at the rocks again, and the absurdity starts to feel plausible. In museums, Ediacaran fossils often look like abstract art. Children peer at them and say, "It looks like a leaf," or "It looks like a pancake," or "It looks like someone's drawing." Adults frown and read the captions, which usually say something vague like "enigmatic fossil," "affinities uncertain." Everyone walks away bemused, and perhaps that is the point. Maybe these fossils are not meant to be understood. Maybe they are meant to provoke exactly that reaction: puzzlement, curiosity, imagination. Perhaps their very strangeness is their function. But let us not shortchange the science. For scientists, these fossils are invaluable. They represent the earliest known large multicellular organisms, the first time life left impressions large enough to be seen without a microscope. They prove that by 600 million years ago, life had already reached levels of complexity far beyond bacteria and algae. They show branching, segmentation, repeated patterns, even possible hints of movement. These are not random smears in rock. They are evidence of organized biology, and that in itself is astonishing. They may not be plants or animals as we know them, but they were living systems, coordinated, multicellular beings. They prove that evolution was already experimenting with complexity long before the Cambrian explosion. And yet, that word experimenting is where the imagination catches fire. Experiments suggest design, testing, purpose. What if these organisms were not Earth's experiments at all? What if they were designed elsewhere, by intelligences older than our sun, and seeded here to see what would happen? In that case, the fossils are not just evidence of biology. They are receipts. They are tags left behind to mark that the experiment occurred. The disc shapes, the branching fronds, the quilted mats. They could all be signatures, logos, trademarks of alien biologists, property of the cosmos, stamped into stone. The notion is wild, yes, but it scratches at something real. The fossils refuse to be pinned down. They give us form without function, bodies without behavior, life without lineage. They taunt us with their clarity and their mystery. They are like riddles carved into the planet's crust, left unsolved for 500 million years. And like all good riddles, they allow multiple answers. Science offers one. These were early multicellular organisms, now extinct, belonging to no modern group. Conspiracy offers another. These were messages, codes, signals from beyond, written in the alphabet of biology. All the way, the fossils achieve something profound. They remind us that Earth's past is stranger than its present. They remind us that life is not confined to our categories. They remind us that sometimes evidence looks like art, sometimes like code, sometimes like both. If you stand before a slab of sandstone covered in Ediacaran fossils, you may feel something uncanny. The ridges and patterns seem familiar and alien at once. Like half-forgotten symbols, they draw the eye, they tease the mind. You may find yourself trying to read them as though they were sentences written in some ancient tongue. And perhaps in a sense they are. Whether written by evolution or by something beyond evolution, they are the first great inscriptions of complex life on Earth. And here is the most delicious irony. Even if they are just organisms, even if they are just fossils of long-vanished life forms, they have still become code. We read them endlessly, we debate their meaning. We interpret their shapes like detectives parsing ciphers. The fossils may not have been intended as messages, but they function as messages nonetheless. They tell us life is old, strange, and unpredictable. They tell us our categories are too narrow. They tell us Earth has secrets it will never explain. So are Ediacaran fossils evidence or code? Science says evidence. Conspiracy says code. Earth, if it could speak, might chuckle softly and say, both? Evidence you cannot decipher, code you cannot prove. And perhaps that is the point. Perhaps the fossils were never meant to be fully understood. Perhaps their role is to haunt us, to remind us that 500 million years ago, Earth was stranger than our imaginations, and that even now, with slabs of stone laid before us, the truth remains just out of reach. So the next time you see one of those fossils, whether in a museum in London, a slab in Russia, or a sunlit outcrop in Australia, Let yourself smile. Science will tell you it is evidence of early multicellular life, enigmatic and extinct. Conspiracy will whisper it is code, a message from the stars preserved in stone. Earth itself might lean in and say, go ahead, try to read it. You won't succeed, but isn't it fun to try? And maybe that is what the fossils are. Not just imprints of life, but imprints of wonder. 500 million years old, and still making us laugh, speculate, and dream. Science is supposed to explain. That is its role, its promise, its contract with curiosity. Yet when science turns its gaze upon the Ediacaran period, it falters, it stammers, it produces papers with cautious phrases like enigmatic affinities, an uncertain placement. It shuffles the fossils into diagrams of the tree of life, only to find they don't fit anywhere. They are not sponges, not worms, not corals, not plants, not fungi. They are multicellular, yes, but multicellular what? They stand outside the categories, like guests who arrive at a party without invitations, wearing costumes no one recognizes. And science, normally so confident, is reduced to muttering, we don't know. This is the first great puzzle. Life on Earth is usually traceable, from bacteria to eukaryotes, from fish to amphibians, from dinosaurs to birds. There is continuity. There are branches, roots, leaves on the evolutionary tree, but the Ediacaran organisms seem to dangle in midair, unattached. They appear, they flourish, they vanish, and leave no clear descendants. If the Tree of Life is a family album, the Ediacaran pages are filled with portraits of strangers who never appear again. Who were they? Why did they not lead to anything else? Why do they look so utterly alien compared to later creatures? Scientists wrestle with these questions, producing hypotheses. Some argue the Ediacaran organisms were early animals, precursors to forms that later evolved more familiar features. Others suggest they were experiments that failed, evolutionary dead ends that could not adapt to the pressures of the Cambrian. Still others think they belonged to an entirely separate kingdom of life, now extinct, with no modern analogues. Each idea carries weight, yet none fits perfectly. The structures are too strange, the gaps too wide, the connections too elusive. The Ediacaran remains the unsolvable chapter in Earth's history. And here, into the silence, the conspiracy steps. Because if science cannot explain these organisms, perhaps the problem is not lack of evidence, but interference. Perhaps the confusion is intentional. Perhaps someone has hidden the truth. It sounds dramatic, but conspiracies thrive on drama. Imagine a cosmic hand erasing connections, blurring lineages, deleting evidence so that no one can trace the origins of these beings. Why? To conceal the fact that they were not from Earth at all. To protect the secret that they were seeded from elsewhere, designed, planted, and then removed. In this light, the confusion of science is not accident, but consequence, exactly what you would expect if the real answers were hidden behind a veil. There is even a delicious irony in the way scientists write about the Ediacaran. The language is full of hedges, may represent, possibly related, affinity uncertain. It reads almost like coded messages itself, as if the researchers are whispering, we know something is off, but we cannot say it aloud. The conspiracy-minded reader sees this as evidence not of humility, but of suppression. They know more than they admit, the voice said. They have been told not to connect the dots. Is that fair to the scientist? Of course not, but it is irresistible when the mystery is this deep. One of the strangest aspects is the body structure of Ediacaran organisms. Modern animals share basic traits: mouths, guts, symmetry, organs. Plants share theirs: roots, stems, leaves, photosynthesis. Fungi have hyphae, spores, networks, but the Ediacaran designs sit outside all of these. Quilted bodies, fractal fronds, discs without faces, ridges without purpose. They do not read like blueprints of familiar life. They read like drafts from another architect entirely. Science calls them body plans. Unlike any seen today, conspiracy calls them the handwriting of alien engineers. And here is where the humor slips in, because the idea of alien engineers designing quilted sea rugs and fractal trees is both absurd and delightful. If you were going to plant life on Earth as an experiment, Why not make it spectacularly weird? Why not design bodies that look like cosmic pillows, floating leaves, or living pancakes? Maybe the goal was not survival at all. Maybe the goal was confusion. Maybe the beings were created simply so that, 500,000,000 years later, humans would scratch their heads and laugh nervously, wondering what on Earth or beyond Earth was going on. Science, meanwhile, has tried to use the Ediacaran puzzle as a springboard for broader inquiry. If these organisms do not fit into our categories, perhaps our categories are too narrow. Perhaps life can take forms we have not imagined. This leads to an exhilarating thought. If we discover life on other planets, will it resemble Earth's plants and animals, or will it resemble the Ediacaran, soft, strange, unclassifiable, resistant to every attempt at categorization? The Ediacaran may not only be an ancient puzzle, it may also be a review. It may be the universe's way of saying, don't be surprised if life elsewhere looks nothing like you expect. Here, science and conspiracy find unexpected agreement. Both suggest the Ediacaran is a model, a demonstration, a clue to how life can manifest under different rules. Science frames it in terms of evolution and biology. Conspiracy frames it in terms of cosmic design and hidden intent. Both acknowledge the same truth. The Ediacaran breaks our categories, and in breaking them it expands our imagination. But the conspiracy angle always adds a darker twist. If the Ediacaran was indeed a message or a test, why the secrecy? Why erase its connections? Why leave it dangling, unsolved? Perhaps, whispers the conspiratorial voice, because the truth is too destabilizing to admit that Earth's early multicellular life came not from evolution alone, but from extraterrestrial seeding would shatter our sense of uniqueness. Perhaps someone or something wants that truth concealed, hidden behind a fog of confusion. The fossils remain, but the clarity is gone. The organisms existed, but their meaning is withheld. Science shrugs, conspiracy nods knowingly. Humor, again, makes the thought bearable. Imagine a galactic bureaucracy filing a report, Ediacaran Project, status, terminated. Evidence partially obscured. Locals will be confused. Mission successful. You can almost hear the cosmic laughter. Earthlings, 500,000,000 years later, still struggling to classify quilted sea rugs, still scratching their heads, still lost in translation. Perhaps that was the whole point. Yet, beneath the humor lies a serious and thrilling implication. If we cannot explain the Ediacaran with our categories, perhaps it shows us the limits of human science itself. Perhaps our frameworks, animal, plant, fungus, are inadequate for describing the full range of possibilities. Perhaps life in its deepest essence is not bound to categories at all. The Ediacaran becomes then not a failure of explanation, but an invitation to rethink what explanation means. Instead of asking, what were they? We might ask, what does it mean to be alive? That is the gift of confusion. It forces us to expand, and in that expansion lies application. Astrobiologists, scientists who study the possibility of life beyond Earth, look to the Ediacaran as inspiration. If life on our own planet once took such alien forms, then surely life elsewhere could too. We must not expect little green men, or even Earth-like plants and animals. We must be ready for bodies that make no sense, structures that defy classification, beings that look more like geometry than biology. In this way, the Ediacaran is practice. It is a training exercise. It prepares us to look at the unfamiliar and not dismiss it, but study it, honor it, learn from it. Of course, the conspiracy-minded twist. This too. Astrobiologists are studying the Ediacaran, they whisper, because they know it was not Earth's. They know it was seeded. They are trying to decode it, to prepare for contact. In this telling, every scientific paper is a cover for a deeper agenda, every cautious phrase a nod to hidden knowledge. Are scientists confused, or are they pretending to be confused? The suspicion lingers, playful and unnerving at once. In the end, the truth may be simple. The Ediacaran is confusing, because life was experimenting, and experiments don't always leave clear trails, or it may be extraordinary. The Ediacaran is confusing because it was never Earth's to explain, because it was planted and erased by hands unseen. Science leans toward the simple. Conspiracy leans toward the extraordinary. Earth, if it could speak, might whisper mischievously, "Don't dig too deep. Some secrets are meant to stay confusing." And perhaps that is the heart of it. The Ediacaran confuses because confusion is its legacy. It is a reminder that life is bigger than our categories, stranger than our theories, and perhaps even stranger than our imaginations. It is science's embarrassment, conspiracy's delight, Earth's secret joke. It resists explanation, and in resisting, it teaches us humility. So let us not fear the confusion. Let us embrace it, for in the bafflement of science, in the whispers of conspiracy, in the laughter of Earth itself, the Ediacaran continues to do what it always did, surprise. And maybe that is the greatest gift of all, a mystery too big to solve, but too delightful to ignore. And so we come to the end of our journey through the Ediacaran, a chapter of Earth's story that feels less like history and more like a riddle whispered across time. Strange beings with soft bodies, an environment that seemed almost staged, fossils that look like coded messages. The Ediacaran stands apart. It is the age that refuses to be explained, the one that slips away each time science tries to pin it down. Was it simply Earth's first great experiment, a rehearsal before the drama of the Cambrian? Or was it something more, an experiment not of Earth at all, but of the cosmos? Were these creatures and their patterns signs of natural evolution? Or were they seeds, messages, prototypes left behind by intelligences we cannot yet imagine? Science shrugs, conspiracy smiles, and Earth itself remains silent, as if guarding its most ancient secret. That is perhaps the real wonder, that even after 500 million years, the Ediacaran still has the power to unsettle, to inspire, to make us dream. It reminds us that not everything can be explained, that mystery has its own value. The strangeness of those forms, the silence of their disappearance, the stubbornness of their fossils, together they weave a lullaby of unanswered questions. So tonight, as you drift towards sleep, let your mind wander back to those ancient seas. Picture soft creatures drifting like living symbols. Imagine the seabed as a cosmic canvas, and ask yourself, were we witnessing Earth's first experiment, or the universe's hidden design? Perhaps the answer will never come. Perhaps the Ediacaran was meant to remain unsolved, a gift of wonder rather than certainty. If you've enjoyed this gentle dive into one of Earth's strangest chapters, share your thoughts, let your imagination play, and remember to like and subscribe. And now, let the ocean of sleep carry you, soft and calm, into dreams where ancient mysteries drift beside you. Good night, and may the secrets of the Ediacaran follow you into the stars.